Hello, Mr. Rast here. This is my third lesson on the topic of energy and states of matter. So far, we have talked about just the vocabulary of what temperature is and how we measure it, and we've talked about specific heat, and that is the heat required to change the temperature of a substance. I'm going to talk about a different form of heat in this lesson, and this is a heat. This is the type of heat that happens during a phase change. And if you ever think about it, why do you shiver when you get out of a shower? And I know a lot of people might just think, well, I'm cold when I get out of a shower because it's warm water, and then when I get out of the shower, it's cold. But you know what? If you even took a cold shower and it's warmer in the bathroom and you have cold water on you, you still are cold when you get out of a shower. And the reason for this is because of the water undergoing a phase change on your body. The water on your body evaporates from your skin. So heat from your skin is being removed from your body to turn the water from a liquid into a gas. It's going through a phase change. And so as the heat is removed from you to make this phase change, you feel cooler because you're losing that heat. So we talked about this diagram, a phase diagram, in the first lesson on this topic. If you want to go back and refer to that, we talked about what a phase diagram and these different changes of matter, or changes in states of matter in this vocabulary here. So go back to that one if you need some refresher on what phase diagrams. But it's important right now that you understand these concepts: the change, what fusion is, solidification, vaporization, condensation, sublimation, and deposition. The change from a solid to a liquid, or vice versa, would be solidification. That's going to come into play here because we are talking about the energy to make those transitions. That energy is called latent heat. This is the energy gained or lost during a phase change. So those were all phase changes on that last slide. They were talking about phase changes. So the heat of fusion is a phase change from a solid to a liquid. So let's just go ahead here. The heat required to vaporize 1 gram of a liquid is called the heat of vaporization. And so I will talk about the change in heat energy, which is this capital H is actually a term called enthalpy, which we'll get into that later. But I'm talking about vaporization here because there's a lot of different phase changes something can go through. And this is just what I'm talking about, vaporization, a liquid becoming a gas. So to vaporize the liquid into a gas, that's heat of vaporization. The heat required to melt 1 gram of a solid is called its heat of fusion. So delta H of fusion. So all of those things have a different latent heat value. Here is a list of constants that I will have available for you to download off of my page. But if you were in my class, you should have a copy of this, and you should pull it out at this point because we will be using this. If you don't, you can always just kind of skip back in the video and refer to these constants here. But next thing I want to do is teach you how to read this. How do we read these constants? So if we look at the first line on these constants, the first line, I'll just go back to show you. The first line was water, heat of vaporization, and heat of fusion. So now let's look here. So water, this is just the first line of that handout I showed you right here. So what this means is, to read this properly, that water, the heat of vaporization it's 2,259.2 joules per gram. That means that it takes 2,259.2 joules to vaporize 1 gram of water. So that's saying that to go from a liquid to a gas, 1 gram of liquid to 1 gram of gas, the heat of vaporization is 2,259.2 joules per gram. To understand this one here, the heat of fusion is the change from a solid to a liquid, and that takes 333.6 joules per gram. Again, you should be familiar with those phase diagrams on what fusion and vaporization is. There's other things that are on that diagram that aren't on the table I gave you, like what is solidification, or what is the heat of condensation. Those, so the energy to heat to vaporize something is for it to condensate would be the exact opposite of that value. So if it takes 2,259.2 joules per gram to vaporize some water, then if a gram of water condensated, it would release that much energy, because energy is neither created nor destroyed. It's conserved, so it can change, but it doesn't get created or destroyed. So if you're going to use energy to do this, to the reverse, to go from a liquid to a gas, the reverse, a gas to a liquid, would release the same amount of energy. So you should know, and I would write on your table, that the heat of vaporization, you could say heat of condensation, is this the negative of all these values? If you just put a negative there, that's the heat of condensation. And if you put a negative in front of the heat of fusions, that's the heat of solidification. Okay, so now we know how to read the table. Let's look at a practice problem with latent heat. What is the energy change when 54.0 grams of ammonia condensates at its boiling point? If you think you want to give it a try, pause the video and give it a shot. And I'm going to walk you guys through it right now. So, what do we know? Well, I know that there's 54 grams of ammonia. I also know I'm solving for energy. I know my mass. And ammonia condensates at its boiling point. So I'm talking about the condensation. And I need to know that condensation is the negative of vaporization. So I can look at my table and I can look up the value of vaporization. So let's just look at our table. The ammonia vaporization here. So condensation would just be the negative of this value, because condensation would be the negative of vaporization, and I'm dealing with ammonia. So that's where this number came from, right here. Now, the way I solve this, I actually like latent heat problems. It's pretty easy to solve. In the first topic, we talked about data analysis, and one of the things I taught you guys was dimensional analysis. And with dimensional analysis, you just use a setup to cancel out units. So if we know that it's a value of joules per gram, and I'm in grams, I can set this up to cancel my units out. I just put the grams as my denominator so I can cancel out. If, for instance, I had joules here, I could invert this to cancel the joules out and solve 4 grams. But anyways, 54.0 grams cancels out. We multiply it by negative 1,368.1 joules per gram. This cancels out. The units left over is joules. And we have a negative value. We should have a negative value here. I've got 3 significant figures here, so my answer has 3 significant figures. And I have a unit in my answer too. Make sure you do all that. So here's some practice problems with latent heat. Calculate the heat required to melt 25.7 grams of solid methanol at its melting point. So we're going to have to look up methanol, and I'm going to have to figure out to melt. What is that word that means melt? Is that fusion? What is the heat energy in joules change when 275 grams of ethanol gas condenses to a liquid at its boiling point? And then what is the mass? So this one here, we've got the energy, so I could invert it like I was telling you before. You might want to back up the video and look at what I was talking about with dimensional analysis on how to solve this one. And don't forget, this is in kilojoules, and your values, are they in kilojoules? Your constants are in joules per gram, so don't be tricked. Make sure you keep track of your units, that this is a kilojoule, not a joule. So be careful on this one. Anyways, good luck with this. Give it your best shot, and then we'll go over them in class. You can leave messages and ask for help. That's what I'm here for. Good luck.